Dear students, in today's video we are going to discuss the numericals based upon the electric field line. In the previous video we have discussed the theory part of the electric field lines. In this video we will go for the numericals. The first question is saying what are the signs of Q1 and Q2? You are given with this figure. This charge is Q1 charge. This is your Q2 charge. You are supposed to determine the signs of Q1 and Q2. For the signs, you have two options. The sign of the charge can be positive and the sign of the charge can be negative. We know that electric field lines move away outward from the positive charge. So if you look at the Q1, all the lines are moving outward from the Q1 charge. It means that Q1 is a positive charge. Positive charge. If you look at the second charge, that is Q2, the lines are moving inward toward the Q2. It means your Q2 is negative charge because electric field lines converge at a negative charge. Okay, so first portion is solved. What are the signs of Q1 and Q2? We have determined that Q1 is positive and Q2 is negative. Now we are supposed to determine the ratio Q1 by Q2. Q1 and by Q2 directly depends upon the number of lines around Q1 and number of lines around Q2 because the charge strength depends upon the density of lines around it. So, if you look at the Q1, there are 1, 2, 3, 4, 5, 6, 7, 8. 8 lines on this side and 8 lines on this side. So, there are total 16 lines which are coming out from the charge Q1. For Q2, total 8 lines are entering inside. So, it is 16 by 8. So, you have your answer 2. So, Q1 by Q2 is equal to 2. So, you have determined the second portion also, that can you determine the ratio of Q1 by Q2? Q1 by Q2 is equal to 2. Now, let us move to the second problem. In figure, the electric field lines on the left have twice the separation as that of on the right? If here the right hand side, the separation between the lines is x, then on the left hand side, the separation between the electric field lines is twice of x. So, the first question is, if the magnitude of field at point A is 40 Newton per Coulomb, means for this particular point A, you are given with the magnitude of the field that is 40 Newton per Coulomb. And we know that these are units for the electric field, SI units for the electric field. So, what is the force acting on the proton? So, the one thing which you are given is electric field, that is 40 Newton per Coulomb. The second information which the question is giving, that you have a proton and you know that the charge on the proton is 1.6 into 10 raised to power minus 19 Coulomb, right? And we know that electric field can be written as force divided by the test charge. So we are supposed to determine the force. Force will be E into Q naught, right? Q naught, the test charge is the proton. So we can simply write force is equal to E. We substitute the value of E, which is 40 Newton per Coulomb, and we have taken the units of charge in Coulomb, so there is no need of unit conversion. So it will be F is equal to 40 into 1.6 into 10 raised to power 19 Coulomb. Then from here you can determine the force. Pick up your calculators and let me know the value of force. In the meanwhile, let me explain the second question. What is the magnitude of field at B? Means you need to calculate the magnitude of electric field at this point B. You know that the magnitude of electric field is dependent upon the density of the number of lines. As the density of number of lines has reduced, here the lines were dense, the distance between the lines was x. Now the distance between the x lines is 2x. When you have moved to the left hand side of the figure, it means that the field strength will reduce by a factor of 2, because density of lines has reduced by a factor of 2. So field at point B will be 20 Newton per Coulomb. When you simplify that, then you have your answer as 6.4 into 10 raised to minus 18 Newton. Newton are the SI units for the force. Question number 3. We are given with a figure, this particular figure. We are supposed to determine the point charges 1, 2, 3. We are supposed to find that what is the nature of charges, whether they are positive charges or the negative charges. The given options are plus, 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 means the charge 1 is positive, charge 2 is positive, and the charge 3 is positive. The second provided option is plus, minus and minus. The third provided option is plus, minus and plus, and the fourth option is minus, minus, minus. So let us look at the charge 1. This is charge 1, and you see there all the lines are coming out from it. Means if the lines are outward, means this first charge is a positive charge. Let us look at the second charge. The lines are coming inward. Inward means this charge will be a negative charge, because for the negative charge the electric field lines converge at the negative charge, and for the positive charge the electric field lines diverge from the positive charge. And for the third charge, again electric field lines are coming inward. It means the third charge is again a negative charge. So if I write 1, 2, 3, for 1 I have positive, for 2 I have negative, and for 3 I again have negative. So which option is correct? So the option B is correct. Now let us move to the question number 4. In question number 4, they have given this figure, right? And they said you among these 4 options, 1, 2, 3, 4, which option will you consider? There are 2 points. One is this area at which the electric field is EP. Another is this at which electric field is EQ. And you can clearly see that the electric field is non-uniform, because the electric field is changing its direction as the lines are curved, right? So as the lines are curved, electric field is changing its direction. It means the first option is wrong. So in case of non-uniform field, electric field at point P cannot be equal to electric field at point Q. Second option, electric field at point P is less than the electric field at point Q. So electric field at point Q, you can see that only one electric field line is passing through it, right? While in case of P, you have almost 3 lines in the area, right? So this option is not correct, because density of lines is less at point Q, right? So this option is not correct. Obviously this one is the correct answer, because the density of lines is high at P area. None of the above is not again an option, because we have already find our answer. Let us look at the 5th problem. So, a long cylindrical shell carries positive surface charge sigma in the upper half. So, in the upper half, this is the upper half in which the positive charge is there, and the charge density is given as sigma, and at the bottom half the negative charge is there, which is written as minus sigma, right? So the electric field lines around the cylinder will look like the figure given in. Means you are supposed to answer which one is the correct view for your electric field lines. Right? So if you calculate the net charge on this long cylindrical shell, it will be sigma plus minus sigma, which gives you the answer as 0. Means net charge is 0. If there is no net charge, means there should be no electric field line coming out from the shell, right? So if the lines will come out, it means it's a positive charge. If lines will go in, it means the charge is negative, right? But if there is no net charge, it means no line should come in or out, right? So if you look at the figure B, for the positive they have drawn the outward lines, and for the negative they have drawn the inward lines. But as the net charge is 0, this option is not correct. For the figure C, they have drawn the positive lines are going toward the infinity. Similarly, they have drawn the negative lines are coming from the infinity. This is incorrect because the net charge is 0, right? And for the fourth option, they have drawn 2 loops here. The electric field line starts from the positive charge and ends at the negative, but they have drawn these 4 lines in the upper portion going out from the positive charge, and at the bottom portion 4 lines coming toward the negative charge. This option is again incorrect. The first option is correct because the electric field line starts from the positive charge and it ends at a negative charge. Right? So electric field line starts from here and ends over here. Electric field line starts from here and ends over here. Similarly on the another side, right? So electric field line starts and ends. So electric field line starts from the positive charge and ends at a negative charge. We have a cylindrical shell. Upper portion of this cylindrical shell is charged positive and bottom portion is charged negative. So if you draw the electric field lines, it starts from the positive and ends at the negative. Similarly this side, again it starts from the second positive and ends at the negative. Then third line, the electric field line starts from the positive and ends at the negative. So arrows will be like that. The lines are coming out from the positive and ending at the negative. So if you view from the away portion, you will find no electric field line coming out. Electric field line coming out from the option A. So option A is the correct answer, which is providing you the net charge as 0. No electric field line is coming out. Next is the question number 6. In question number 6, you have 3 equal positive charges placed at the vertices of equilateral triangle. So this is an equilateral triangle in which all the 3 sides are equal. You have mounted positive charges. Say I put Q1 here, Q2 here and Q3 here at the vertices of an equilateral triangle such that Q1 is equal to Q2 is equal to Q3. All the charges are equal, and the one thing is that all the 3 charges are the positive charges. Find out the electric line field sketch. You need to find out that among these 4 which one is correct, right? If you look at the option D, electric field lines are forming a closed loop, which is not possible because closed loops are found in magnetic field lines, not in electric field lines. So one of the option is gone because the electric field lines cannot make the closed loop. If you look at the option A, the electric field lines is starting from Q1 and it ends at Q2. What does this mean? Electric field starts from here and ends here, and starts from here and ends here, which is not possible because electric field lines starts from a positive charge and ends at a negative charge as per the property of electric field lines. So this option is gone. In the option C, if you look, the electric field lines are crossing each other. So at these points, the electric field lines are crossing each other, but the electric field lines cannot intersect each other. Because if they will intersect each other, then at the point of intersection, they will have two directions, and this is not possible. The correct option is B. So if you draw the things, this is charge Q1 which is positive, this is Q2 which is positive, and this is Q3. So electric field lines are drawn in this way. Similarly for the second charge. So the option B is the correct answer. Question 7. Two field lines are symmetric about the line joining the two charges. This is the first charge Q1, this is the second charge. This is the line joining the two charges. The field lines are symmetrical about the line joining the two charges. Right? We have to check whether Q1 is greater than Q2, Q2 is greater than Q1, Q1 is equal to Q2, or none of the above. This can be checked by knowing a simple thing, that if you have a plus Q1 charge here, if the four lines are coming out of it, then the angle between these lines will be 90, 90, 90, right? Total angle 360 divided into 4 portions will give me 90, 90 each. If I make another drawing in which the Q1 charge is at the center and 8 lines are coming out from it, then each angle will be of 45 degree, 45 each. So what comparison you made? You made the comparison that number of field line increases, it result in decrease of angle between the field lines. If your charge is stronger, it has greater strength, then the angle between the field lines will be smaller, right? So Q2 is a stronger charge because theta 2 is less than theta 1. So which one option is correct? The option B is correct, which says that Q2 is greater than Q1.